A helicopter is carrying a block of mass 12 tons, which is suspended by a vertical light inextensible wire. Initially, the helicopter is hovering and there is no vertical motion. If the block then descends vertically with an acceleration of 2 meters per second squared, how much time does it take for the speed to increase to 12 meters per second to the -1 from rest? How far does the block descend in this time? Calculate the tension in the wire when the block is being lowered vertically with an acceleration of 2 meters per second downwards and with an acceleration of 1.5 meters per second upwards. So we got initially it's at rest because it's hovering, and then it's going to move down with an acceleration of 2 meters per second squared. So we've got A is 2 meters per second squared. So extracting the information from the question, U is 0 meters per second. The initial speed is 0 because it's hovering with no vertical motion, and we're sort of considering vertical motion here. V is 12 meters per second squared. We want to find T and how far it moves in that time T. So taking positive as downwards, then we're going to use V is equal to U plus AT. So we're going to have that 12 is equal to the initial speed, which is 0, plus 2 times t. That gives me that 2t is equal to 12, and therefore the time would be 6 seconds. How far did it move in that 6 seconds? Well, if we use s as ut plus a half at squared, we're going to get that s is 0 times 6 plus a half times 2 times 6 squared. Half times 2 is 1, 6 squared is 36, so the displacement is 36 meters. We could also use the formula v squared is equal to u squared plus 2as, and that will give me the same answer as 36. You might want to stop the video and try that for yourself. Right, now to do the calculate the tension when there's an acceleration of 2 meters downwards and it's been lowered vertically. So the first step, obviously, is to draw the force diagram on the block. So we've got, it's a 12-ton block, so that means it's 12,000 kilograms. We've got the weight of 12,000 times g newtons acting downwards. We've got the tension acting upwards. And we've got an acceleration of 2 meters per second downwards. So resolving the forces, and we're going to take positive as downwards. So we're going to have 12,000 g minus t is equal to the mass, which is 12,000, times the acceleration, which is 2, and that's Newton's using Newton's second law. We're now going to find t from that. So we're going to have 12,000 g minus 24,000, that's 12 times 2,000 taken over here, and the t taken over to here is equal to t. And then we're going to have that t is going to be 93,600 newtons. Right, in the second case, we've got the same mass of 12,000 kilograms. We've got the same weight acting downwards, and we've got a different tension probably acting upwards. But the acceleration, okay, is going to be, because the acceleration is acting upwards, then we're going to say it's acting against our downwards movement. So we're going to say the acceleration is minus 1.2 meters per second squared, mainly because we're actually still lowering the block. So the acceleration is acting against the block, i.e. probably slowing it down. So positive is downwards, so we're going to use 12,000 g minus t is equal to 12,000 times minus 1.5, because the acceleration is acting upwards. So that's going to give me 12,000 g minus t is equal to minus 18,000. Rearranging, we're going to get 12,000 g plus 18,000 is equal to t, and therefore t will be 135,600 newtons. Okay, so this has been a video to show you about the tension in a vertical motion where the acceleration, where a block has been lowered downwards, but initially the acceleration is acting in the same direction downwards, and then the acceleration is acting upwards. Thank you very much for watching, and I hope you've understood.